In this video, I'm going to investigate what gets hot inside this power supply. If you want to see a video which investigates the components that get hot inside this power supply and causes it to overheat, then this is the video for you. So let's go. So I'll start by taking the unit to pieces. I haven't actually totally taken this to pieces yet, so this is going to be a first time for me also. So I think we've got 4 screws that hold the back panel in and 4 screws that hold the front panel in. Had the front panel off before. Haven't had the back panel off yet. That seems to be quite tight. Okay, so the power supply in the middle is just held in with these 4 screws. The feet are totally separate, so I think if I just take these screws out, then the power supply should probably fall out. Doesn't actually fall out. Slides out to the rear. Can I feed the front panel through? Yes, I can. Okay, let's get that out of the way. Right, so we have the back panel. I'll turn it around the other way because my power supply is actually the other way, the main supply. So we have the switch mode power supply here. It's got 2 outputs, which are marked V1, GG, V2. So I guess we could start just by seeing what's actually coming out of those guys. So let's connect the mains. Power on, yep. Right, let's just see what voltages we've got coming out. So on the back panel I've just got 1 green LED on the inside, sorry, on the inside of the front panel I've just got 1 green LED there, and I can just see the red LED, which is the panel illumination. So let's just check to see what output voltages we've got. So ground, so this is V1, so 48 volts, and V2 is at 24 volts. So I assume that the V1 is actually for the main power supply, the 48 volts, and then the V2, the 24 volts, is for the PD power supply. It has got an adjustment potentiometer on the power supply as well. And there is another terminal. It looks like it could be for a fan, possibly. Okay, let's just turn the power off again. see how quickly the voltage drops. Yeah, so the output of the power supply drops relatively quickly. Do that again, power on, power off. You can see how quickly that drops down. Okay, so what I'm going to do next is I'm going to get a load and my thermal camera. Then we'll be able to see what's generating the temperature inside this unit. So I'll just get that set up and I shall be back in a moment. At the moment I've got nothing connected to the power supply at all. So we've just got the front panel here. I think it's the output is set for 18 volts. Other than that, there's nothing connected. So let's just have a look through the thermal camera. Unfortunately, I haven't got a particularly high resolution thermal imaging camera, but this should do the job. So I have let it cool down a little bit, so we can see the transformer there is at 28 degrees. The hottest part appears to be one of the capacitors, which is currently at about 28 degrees on the power supply. And again, the capacitors on the front panel appear to be the warmest part. That one's at 36 degrees. That one is at 32 and 28. Other than that, the heatsink itself is at about 28 degrees and everything else appears to be cool. So the first thing I'm going to do is literally just going to switch the thing on. So we should have output. So the switch mode supply is giving output, but there's nothing on the front panel because the output is off. So let's just have a look to see what happens here. Okay, immediately something is warming up. Something is warming up a lot. It appears to be that there's a resistor. It appears to be, I don't know if you can see that, there's a resistor right there. It appears to be that resistor that's getting hot. Yeah, it's already up to 68 degrees. Okay, I do have a macro lens. Let's pop the macro lens on. Yeah, 80 degrees. It's definitely that resistor. 90 degrees. Let's just see what it maxes out at. Okay, so that resistor with no load on the power supply whatsoever is currently at 94 degrees, which isn't really, I wouldn't consider that to be very good at all. 95 degrees. Oh, hang on, let's just check the front panel here. So what have we got? Let's take the macro lens back off again. So let's have a look. It's all quite cool. So we've got a bit of warmth there, which is a capacitor, 34 degrees. The heatsink is currently 28 degrees. Those capacitors 28, so nothing has really changed on the front panel. I've got a little bit of extra warmth over here, which is just those surface mount components, but again nothing major. 30 degrees. Okay, so let's turn the output on. So output is on, the LED's gone green, 18 volts output, but obviously no current. That resistor is now at 108 degrees, 109 degrees, 110, 111. So it's about 110 degrees, that resistor. I think it's a 2K resistor. What else have we got going on? So the heatsink is at 30 degrees. That's 43 degrees. But we've got nothing over 40 degrees at the moment. Right, okay. So I'm going to switch off. I'm going to apply some load now. So I've just got my electronic load connected. I've got it set to pull maximum current. So we've got the output voltage set at 18 volts. Current limit is set at 8.2 volts. So the output is on. Okay, so let's see what gets hot. Power on. Okay, so we're pulling 8.2 amps. Okay, actually just pulling 8 amps. You can see that. Yep. Right, let's have a look in here. So that resistor is currently just over 100 degrees, 110 degrees. Transformer's warming up. The fan has just kicked in, so the transformer's at about 45 degrees. Okay, so we're getting some major heat build up here now. So the heatsink is up to 38, 45, I believe that's the fuse. Actually, the fuse itself is getting quite warm. Fuse is 42 degrees. That fuse is, wow, is that the fuse? 88 degrees. Let's put the macro lens on. Yeah, that is the fuse. So the fuse itself is 87 degrees. Heatsink is currently at 46. What's the front panel say? 49. So I would imagine, yeah, it looks as if it's the heatsink that's been monitored temperature wise. That matches up with the front panel temperature on my camera. So that IC is 71. So it's the one on the left. I'll look at the part number of that in a moment. The heatsink is at so the inductor is at 50 and the inside of the heatsink is at 57. Front panel says 59. Oh, the output's gone off, so the output has actually shut down. Let's have a look at the resistor. The resistor's at 95. Transformer is at 47. Which is actually at 112 degrees, and the heatsink, which is back down to 46, and the front panel says 51. Yeah, it appears to be the heatsink, as you'd probably expect. It does feel warm to the touch. Right, what I do have is I've got a fan here. It's a little bit noisy, unfortunately. So I'm going to try and cool that heatsink. Let's turn the output on. Have to excuse the noise, I apologise. Seems that the heatsink is getting hottest down the bottom there. So I'm currently pulling just over 8 amps, 18 volts. And it would appear that I can keep the temperature of the heatsink down with this fan. So let's just have a look at the front panel. Yep, the front panel still saying 36 degrees. So let's take the fan away. Just let that start heating up a little bit. And see if I can cool it with the fan. So it's 40 degrees, it's climbing up, 41, 42, 43, try and get the reflections out so you guys can see, 45, right. Noise for the fan. Yeah, instantly that's coming down. That's down to 40 degrees, 39, 38, 37. And let's turn the fan off. 38, 39, 40, 41, 42, 43, 44, 45, 46, 45, 46, 40. I'll wait for it to get to 50 and then I'll put the fan back on. Okay, 50 degrees. Fan on. Yeah, straight down to basically 40, 39, 38. Okay, so what I'm going to do now, I'm just going to hold the thermal camera over those two ICs. They are in fact MOSFETs. We'll look at the data sheet for those in a moment. So I'm literally just going to put the camera on those, we'll power it up, put some load on and just see how quickly they actually heat up. So the power's coming on now. Okay, so output on. So we've got 18 volts at 8 amps. Fan's just kicked in, 33 degrees. And we can actually see that one of those appears to be heating up a lot more than the other one. There is a capacitor in the way, so half of the image is actually blocked. You can't even see it on camera with all the reflections. How about that? So the one on the left is at 60. Okay, they're both getting equally warm now, but the one on the right is certainly heating up a lot quicker now. I can assume that maybe the heatsink isn't connected so well on that one. They are evening up now. The output has actually switched off. Okay, so these are the devices that seem to be causing the issue. They're the two output MOSFETs, part numbers there. And a really quick look at the data sheet. So it's an NCEP039N10. Drain source maximum voltage is 100 volts. The gate source maximum voltage is 20 volts. Maximum current drain continuous is 135 amps. And the maximum power dissipation is 220 watts. So it would appear that this heatsink needs to be larger, or even larger and have a small fan attached to it. Now looking through my box of heatsinks here, I don't really have anything that's the same size. In fact, this appears to be a very unusual size to me. The actual width of the heatsink itself is about 33 millimeters, and the pin spacing for the PCB mounts is about 27.5 millimeters. So they don't seem to be very standard dimensions to me. So at the moment I'm a little bit stuck. I'm going to go away and see what I can come up with in the way of extra cooling is concerned. In the meantime, I'm going to put it back together and end this video right here. So if you've enjoyed watching this video, or if you found it useful, please give the video a thumbs up, and I would appreciate it if you could subscribe to the channel and check out some of my other videos. And thanks for watching, and I will see you in the next